All right, pre-calc 11, here we go. Doing rational expressions, adding and subtracting. Page 336, 1 to 10. There's some extra ones, 15 and 18 for extra if you wish. So, the last video was multiplying and dividing fractions is fairly quick, relatively, compared to adding and subtracting. So the questions today are going to look very similar to the multiply divide, with the big exception that between the two rational expressions they're going to be asking you to add or subtract. Now, before we tackle these questions, I want to just remind you of adding and subtracting of fractions from grade 9. So let's remind ourselves of these. So remember, when you are subtracting fractions, you must have an lowest common denominator. And if you're fortunate enough where the denominators are already the same, then it is as simple as writing this all over the one denominator, as you know, 5, and then the numerator would be 12, take away 10. In this case, that would be 2 over 5, and then you just check to make sure it's in lowest terms, and then it is, walk away, done. If perchance you're adding or subtracting fractions and they don't have a common denominator, well, then you have to build a lowest common denominator. When it comes to numbers, you're just using your times table and numeracy savvy. So there's lots of denominators you could use here, but the lowest common denominator between 9 and 27 would in fact be 27, because 9 does in fact multiply in or divide into 27 nicely. So what you would then end up doing is you would end up making both denominators 27. This one already is a 27, so you just recopy the denominator. For the one that wasn't a 27 to start with, you would then go back and say, what do I multiply you by? Oh, I multiply you by 3 to make you 27, therefore I multiply the numerator equivalently to make that 21. And then you're back to this type of situation. Denominator the same, keep it the same, add the numerator, 21 plus 1, which I know you just do in your head, and you get 22 over 27. Check to make sure it's in lowest terms. Nothing divides into that numerator except for 2 and 11. That's 3's. So that's done. So remind yourselves, LCD is the most important part. And notice there's really no canceling until the very end, if in fact the very end does happen. So let's look at the next examples where you happen to have the same thing. You're just adding and subtracting fractions, just you have bulkier terms. So first example, simplify and state restrictions. As soon as I see subtraction of rationals, the first thing I would do for these questions that you wouldn't do for a normal fraction question in grade 8 or 9 is I would always, just so important to factor everything. Now, sometimes there's very little factoring to do. Here, 2a does not factor. And technically, it already is 2 times a. b doesn't factor. b doesn't factor. This guy doesn't factor, so I probably would put brackets around it because I've just checked it to make sure it's not a difference of squares. It's just a minus 1. At that point in time, after you factored, then you would build the LCD. And in this case, the LCD happens to be b because that's in common to both. So you can write everything over a b. Then you would go 2a, take away, and here I'm taking away a binomial, so I need to keep that negative affects both. That's why I like the brackets, because then when you distribute out that negative, you're not going to get duped, because that's actually a plus 1. That would be the biggest mistake in that question. And at that point, you can add the numerator with your like terms. So here I get 2a minus a, which is a plus 1 over b. And then at that point, there's no common factor. I would refactor it if I could, but I can't, and then we're done. So there's your final answer. Restrictions, I guess I got carried away a little bit. So factor, build your LCD, then let's state the restrictions. What are the bad values of the denominator? What's a bad value for that is 0, which is both for the same. So I would keep that in my final answer. B cannot equal 0. Okay, so factor, LCD, restrictions, and then it would be basically you're dealing with add, subtract, numeracy of your numerator, and then seeing if you can go back and clean it up. So next example. Again, adding, subtracting fractions. I would factor everything that I could. Doesn't factor, doesn't factor, doesn't factor, doesn't factor. I could make that 2 times 5, but don't feel like it. And everything has the same denominator, so we're very, very, very fortunate. So I can write everything over x minus 2. And then I can just recopy my numerators, this plus this minus that. What are the restrictions on x? Well, can't equal 2, can't equal 2, can't equal 2. That makes all those 0. And now before I walk away from this, I need to double check. Once I've done my LCD numerator move, I just want to double, could this possibly factor further? Is this truly in lowest terms? And then by coincidence, almost the question was cooked up, I tell you. What multiplies to give negative 10 and adds to give 3? That would be positive 5 and negative 2. Let me just double check. X squared minus 2x, 5x is positive 3x minus 10. Good. And then that by coincidence, there's a factor in common, just like the last section, that I can divide out. And you're left with x plus 5 with the condition that x cannot equal 2. And there's your final reduced answer. These are all right answers. It's just this is the simplest. All right, let's look at the ones now where you don't have the beautiful denominators already lining up to be the same. So x squared minus 20 over x squared minus 4 plus x minus 2 over x plus 2. As soon as I see adding of rationals, again, I'm going to factor the heck out of everything. So x squared minus 20. That has difference of squares flavors, but unfortunately 20 is not a perfect square. So even though it could have potentially factored, it doesn't. So because it doesn't, I'm leaving it in brackets. X squared minus 4, definitely a difference of squares. Oops. So it'll be x plus 2, x minus 2. And over here, x minus 2 does not factor, x plus 2 does not factor. Now one thing on here we got to be so careful with. I cannot divide those out. If this was a time symbol here, I could divide these out and cancel those out completely, but you never, ever, ever, ever cancel across a plus sign, ever. So that would be a, if you did that, game over. It just, pedestrian just got struck. Restrictions. What are bad values of x? Well, for this factor, negative 2. For this factor, 2. For that factor, negative 2. So negative 2 and 2. Now, my only hope here is I'm going to build the LCD. Now, how do I build an LCD between these two which are different? The easiest way to build an LCD is just sweep through all of the factors that are there. So the LCD must have an x plus 2 in it in order to cover this. It also must have an x minus 2 in it, because that alone would cover this. And the x plus 2 from here, that would cover that and that at the same time. So you don't need to have x plus 2 twice. It's just once. So there's your LCD. So now what you got to do, and it's clumsy, the only way out is you need to write both of these denominators with your LCD that we've chosen. Go back and look at the original, just like these questions here. When it stays the same, you just recopy this stayed the same. I'm going to recopy that numerator, no change. But this guy here, it has to get multiplied by something in order to become the LCD. I need to multiply the bottom by an x minus 2. But then I have to multiply the numerator by an x minus 2. Equivalent to this move here when we multiplied top and bottom by 3. Same difference, just uglier factors. And now by doing that, I'm just going to rewrite what we just had there. Now this is where it gets weird for people. They get excited and start thinking they can cancel this out, and yeah, you can cancel that out, but then you're defeating the whole purpose of getting a common denominator. The whole purpose of doing this was so you can write this all over x plus 2, x minus 2. I have a tendency of just rewriting the numerator. I don't want to do too much and make a mistake. And then I'm going to clean up this numerator, and it becomes a real pain. Unfortunately, like I said, there's no... And I cannot cancel this because that darn plus sign. There's nothing here to cancel. Nothing. So all I can do is distribute out the numerator. So there's that distributed out. I can distribute this out into x squared minus 2x minus 2x plus 4. If that was a minus sign, I would have been really careful because that minus sign would have also distributed in over my denominator. Collect like terms. So I have 2x squareds. I have minus 4x's. I'm going to put a check mark above them as I'm done. And I have minus 16 for my constants. All over x plus 2, x minus 2. Then I have to double check and just see before I walk away. This has potential in the numerator to factor again. I can factor out a 2. And I get x squared minus 2x minus 8. That could possibly even factor further. Let's see. What multiplies to give negative 8 and adds to give negative 2? That could be a negative 4 and a plus 2. Interesting. So sometimes you just get lucky or unlucky and there's more work to be done. And now, because you've got everything on one big numerator and denominator and you've factored everything, these can cancel because there's no more addition. And your final answer is 2 bracket x minus 4 over x minus 2, with the two restrictions that x cannot equal plus or minus 2. And again, be so careful. I cannot cancel these because those are different factors. And that is your final answer. So it is a pain in the butt. Adding and subtracting is not an easy, it's not a fun process in the sense of things don't really cancel too much. You have to do a lot of grunt work on making the numerator equivalent with your newfound LCD. You have to expand your numerator and do a lot of collecting like terms. It's a pain. And then once you get to there, it's like, can I do more? And sometimes you're done. Other times, in this case, there's a lot of factoring to be done, and then actually canceling happened further just by fluke. Okay, two more examples. So this guy here, let's see what we got going on. Okay, so we're adding and subtracting fractions. First thing I would do with one like this personally, this doesn't look like a fraction, so I'd make it a fraction so it can join in the little reindeer games. Next thing is I would factor everything, but the beauty of this, that's factored, that could be 2 times 2, I'm not going to bother. X squared's factored, they're all little individual packets, so they're already factored. Next thing is I would build my LCD, which has to have an x in it, and that x would cover this x and one of these x's. It also has to have a y to cover that y, and it needs another x to cover the x squared. So you're building a big enough denominator such that it has the power to individually cover each one of these. So x squared y covers this with an extra x left over. X squared y covers this with an extra y left over, and obviously the 1 is covered no matter what. But that's the smallest denominator you could build to cover all 3 things. Once I've done that, I then choose to write all the denominators with my newfound LCD, going back and looking at what it was to start with, what I want. I need this denominator to be multiplied by another x in order for this to happen. So my numerator now becomes a 2x squared. This guy, I look down where I want it to go, I need to multiply it by y, top and bottom. So this now becomes a 4y. And this poor little turkey, it needs to get multiplied by the whole denominator x squared y. So you end up with that. So you just kept it equivalent, but what was the purpose of doing that? It's so you can write it all over one big honkin' denominator and get it as one fraction. Now before I walk away, I want to do the restrictions. What's a bad value of x? 0, because 0 squared times anything is 0. What's a bad value for y? Y cannot equal 0 as well. And then I'm going to rewrite my numerators. It's this plus this minus this. Now when I look at that, first of all, that is a weird looking trinomial. There's no GCF. There's nothing in common to all 3 things, variable or number. And it's not a typical trinomial with like an x squared, an x, and a number. It's not even symmetrical with, so that's as far as you can go. And that's sometimes the hardest part to know. When do I walk away? There's no amount of factoring will make that better. Okay, last one on add subtract. So sometimes you get these complex fractions where you have a fraction within a fraction. So they call these a complex fraction. If you don't like the look of that, feel free to write it like this. It's this whole mess divided by this whole mess. I don't know if that makes it better or worse in your eyes. It depends on your perspective. I kind of prefer this personally. I'll come back to that later, because here, the reason this isn't helpful to me, because when I'm dividing here, I can't reciprocate this because that's not a fraction. I do not have a fraction dividing a fraction. I have a number minus a fraction divided by a number minus a fraction. I cannot use any rules there. But that's what the meaning of this is. What I need to do first, in order for me to use my division rule here, I need to get this to be one fraction and this to be one fraction. So what I'm going to do, let's start here then. It doesn't matter which option. I'm going to put this over a 1, put this over a 1. I want to get this to be one fraction. So what am I doing? I'm subtracting fractions. Oh, I need to get an LCD. Factoring, not much to do. So here, for this particular fraction, I look at that and go, what's my LCD between a 1 and an x? Well, it has to be an x. If I put an x there, I need to multiply this guy by an x and that guy by an x. So now I get 2x, and this stays a 4 because I haven't changed it. At the same time, I need to work on this one. Well, I need to get a common denominator for it. Well, nothing factors between 1 and x. Well, that's an x again. That'll stay a 4. This guy gets multiplied top and bottom by an x, and this turns into an x squared minus 4. Or x squared, sorry, on top. At that point, what was the whole purpose of doing that? Was so this I could write as one fraction and get it to be 2x minus 4. This write as one fraction over x. And now I have a fraction dividing a fraction. I am now allowed to flip and multiply. So make that a time symbol, flip this little turkey around. And what I've done, there's my add subtract move right there. Now it's turned into a multiply divide question. And what do I need to do before I can tackle this? I need to factor it. Does this factor? Yep, I can take out a 2. Does x squared minus 4 factor? Definitely. Difference of squares. And now because it's all factored, there's no adding and subtracting in between anything, I can cancel like factors. This x cancels out with that x. This x minus 2 cancels out with that x minus 2. And you're left with 2 on top, because those are all, it's 2 times 1 times 1. And on the bottom I'm left with an x plus 2. And I should go back and look at my restrictions. Let's go back and look at the very beginning. What's a bad value for these denominators? Well, x cannot equal 0 from here and here. Also, there's another denominator that came along for the ride right here. There's a denominator of x cannot be 2 and negative 2. Those are sneaky. Those might get missed. But there's my answer. And then don't do all that hard work and then divide out those 2's. Because you cannot divide out those 2's because there's a plus sign there. That'd be like having the best driving lesson ever and just going along and doing everything right, shoulder checking. You put your seatbelt on, you've done all the driving right, and then boom, just as you pull into the driving center, you run over a pedestrian. All that hard work, and then if you did that, gone, over. So be careful with that. That is an important skill. Remember, the page number is this guy. Practice those. Look in the textbook as well for the examples in there. Adding and subtracting takes time, takes effort compared to multiplying and dividing. Have a good day. Talk to you soon.